Welcome to the feast where we will be presenting the House Cup.
But first, we would like to award 1 point to Gryffindor for exemplary bravery in the face of mental mathematics.
And 2 points for applying the trigonometric ratios.
You sound like an old man.
And you sound like you're from London.
Oh no, I lost the cap for the stylus.
So anyways, trigonometry can be applied to a whole bunch of contexts. So there are triangles in life just all over the place. Sometimes they're in your math notes. Yeah, that's legit. But sometimes they're also in things like construction-y projects or space projects. Physics is great, by the way. We're going to be looking at some contextual problems. And in those scenarios, we're going to want to draw a diagram pretty much every single time. And in drawing that diagram, we might be able to see a triangle right away, or we might have to kind of draw it in just to see exactly how it's anchored in there. But once we have that triangle, once we have that right triangle, we can determine which measures we know, so which side lengths we know, which angles we know, and which of them that we have to find for that particular context.
Now, in doing all of that, we might encounter some new terms. And they are the angle of elevation or the angle of depression. These angles always have to be drawn relative to the horizon. And the horizon's a horizontal line, which is side to side. And as we're doing that, they're always kind of in reference to our line of sight. So, you need color here. And I guess my eyes are brown too. Boop, boop. Not really great. I have no defined chin here. Boop. Okay.
This is necessary.
So your line of sight is from your eyeballs straight sideways. That is considered to be the horizon. And I don't see that that's really level. There we go. And when we have an angle of elevation, that's the angle between your horizon from your eyeballs straight out upwards. So it's the angle between the horizon and your line of sight when you look up. Now the angle of elevation is this one here. We also have the term angle of depression.
That sounds sad.
Well, it is your line of sight when looking down, so I guess you could remember it that way.
Huh.
So its line of sight when looking down is this purple line here. And your angle of depression is your angle between your horizon and that line of sight when looking down. So angle of depression. Now the key thing to remember is that it's always the angle between your line of sight and your horizon. If your line of sight is upwards, then it's called an angle of elevation. If your line of sight is downwards or below the horizon, it is the angle of depression.
We're going to do some examples. Sometimes the terms angle of elevation and depression will be used. So, here we go. You are standing 179.8 meters away from the CN Tower in Toronto, and you look up at an angle of elevation of 72 degrees. In order to view the top of the tower's antenna, how tall is the CN Tower to the nearest tenth of a meter? So as suggested above, we're going to kick this off with a drawing of the CN Tower. Whoop. Which doesn't have to be the most intricate drawing of your life. You might be aware that I am not an artist, but I'm doing my best, and that's all we can really expect anyone to do. Woo. Woo. And I guess there's a whole bunch of road between you and that tower. And it's you, maybe it's me. And I'm just like right over here.
Ah, you're the little.
But the hair is not. And I'm looking at an angle of 72 degrees, angle of elevation. So here's me, there's my line of sight, so up from that would be my angle of elevation. So I go like from here to me. That's what we're looking at. In this, we could have a little bit of a triangle. So there's this height of the CN tower itself, and there's the distance from it to me. And that altogether forms a right triangle. Things we know about the situation: we know that this angle is 72 degrees, and we know that I'm 179.8 meters away. We could find other stuff here. I suppose we could find this angle if we wanted to. We could find this length over here, but what we're after is how tall the CN tower is, and that's right over here. I'm going to label that as H for height. And with that being set up, I can now solve this. With my angle of 72 degrees, I can go through the processes of noting what each side length is supposed to be. So for that angle, this is my opposite, and this other one is my adjacent. It's not necessary to write that, but if it helps you, go for it. And then we can just tackle this thing. Because that's opposite and adjacent, I'm going to use tan. The definition of tan is that tan theta is opposite over adjacent. Filling in what I know, tan of 72 degrees is H over 9.8. Let's just write that better. And we can solve for H accordingly. According to my mental calculations, that's about 553.4. But you can use a calculator, so don't forget. Very necessary in these contextual problems is that we give a contextual answer. So I should say something like the CN tower is about 553.4 meters tall. Note those units. Those units are necessary. If you don't have them here, you darn well better have them right over there. And that's that example done. Whew.
All right, taking a look at this next example here, we have a 20-foot ladder resting against a wall. It is recommended that the ladder always be an angle of 60 degrees to the ground. How high up the wall should it reach to the nearest whole foot? So for starters here, we have some sort of wall. Oops, that's kind of crooked.
Yeah, who ate those bricks?
So we have some sort of wall. And we have some grass. We're assuming this is outside right now. And we have our ladder. All right. So what do we know about the situation? Well, we could see, hopefully, that there is a right angle triangle that's formed between the wall and the ladder and the ground. Now we could start labeling some of the information that we know. Well, we know that the ladder itself is 20 feet long. So the ladder here is going to be 20 feet. We know that the angle from the ground to the ladder should be 60 degrees. And we want to know how high up the wall it should reach. So we want to know this distance here. Well, this we could label h for height, or we could pick another variable that we feel is suitable. Now, taking a look at what we have regarding to this angle, I know that h would be considered my opposite, and the 20 feet would be considered my hypotenuse. Since I have my opposite and my hypotenuse that I want to use in this question, I'm going to be using my sine ratio. So I know that the definition of sine theta is that it equals to the opposite side over the hypotenuse. And now I could plug in the values. Instead of theta, I know that I have 60 degrees. My opposite is actually now my variable h. That's my height I'm looking for. And my hypotenuse is 20. To get h alone, I'm going to multiply both sides by 20, leaving me with 20 times sine 60 degrees on one side and just h on the other. And when I go ahead and plug that into my calculator, since I'm rounding to the nearest whole foot, I should get 17 feet. Now, because this is a word problem, we should end with a word answer. And it says, how high up the wall should it reach? We could say, I guess sentences with capital letters, the ladder should reach 17 feet up the wall. And again, like Mr. A mentioned, it is necessary that we have the units as our final answer, and we are rounding according to the question.
Next up, we've got Ryan looking out from his office window. Oh, wait. Before I talk about this, don't forget that you can pause things. So try these next two contextual questions. See what you can do, and then you can compare to what we're doing. Don't forget. Them's the rules. I forgot what I was saying. I told them not to forget. We're talking about Ryan. Oh, Ryan's my friend. He's looking out from his office window, probably at Badminton, Manitoba. Classic Ryan, 43 meters up. And he looks at an angle of depression of 37 degrees to see Justin, who also works for Badminton, Manitoba. All right, we gotta find out what's going on here. So, diagram. Let's draw Ryan and his Badminton, Manitoba building. It's Sport Manitoba, really being honest. Doo-doo-doo. They've got, like, windows and stuff. Sure, a door. With a really long sidewalk. So there's Justin, and he's coming to visit Rai, who's just hanging out over here at Badminton, Manitoba with his sleeves that are blue. Ryan is looking down at an angle of depression of 37 degrees. Where to draw that? Good question. I'm glad you asked. Let's figure that out. So he's looking at Justin. Whoop. Wow, Justin's really big, actually. Not gonna lie. I'm just gonna resize that. I'm so sorry. Oh, come on. Worked for me. I swear.
Should have just left him big. It could have been a perspective thing.
Yeah, it could have been, but he wouldn't fit through the door. Anyways, Ryan looking at Justin. Justin, maybe he's looking back at Ryan. Maybe they're waving at each other. where is this 37 degrees going to go? Because we know that we want to know how far Justin is from the base of Ryan's building, which is like that, this distance right here. I'm going to label it D for distance. And we know that Ryan's office window is 43 meters high. So where does this 37 degrees go? Does it go here? No, because that is not an angle of depression. Remember, it's always between that line of sight and what would be us looking straight out. So it's not between a vertical line and another one. It's between a horizontal line and another one. So a couple ways we can tackle this. We can pretend Ryan's looking straight out, and then he has to look down 37 degrees to see Justin. Or we can note that if Ryan has to look down at 37 degrees, Justin has to look up at 37 degrees. So however you choose to see that will work. Because this is also 43 meters. And this is the same distance. We've got rectangles over here to go with our triangles. In any case, we can set this up and go for it. I'm going to use the tan ratio again and say that tan of 37 degrees is 43 over D, which means that D is 43 over tan of 37, which is, according to my head brain, well, nearest whole meter? Oh, then I can get that easily. I think that's like 57 meters. And wordy word answer, where I say Justin's about 57 meters from the base of Ryan's building. Ryan actually no longer works for Badminton Manitoba. He's resigned and he's gone on to do other badminton things.
Right, last but not least, we've got Tim, and he's a pilot. And Tim takes off at a speed of 240 kilometers an hour in his plane. After 5 minutes, the plane is 3.47 kilometers above the ground. At what average angle of elevation did the plane travel over those 5 minutes to the nearest degree? Okay, so there's a lot of things going on here. And maybe the first thing that we could think of is that our plane is taken off probably from the runway. So if that there is our runway, we need to have some sort of plane. And the plane likely took off in that sort of trajectory there. And so let's draw a plane. My planes often don't work very well. I think that they tend to look like weird
That's a
fish.
cool bird.
Right? You just like slap some lips on it. Whoop. It could be a fish.
So I'm still thinking about Tim taking off at 240 kilometers an hour without a plane.
Anywho, there is our plane, and we want to know at what average angle of elevation. So we want to know this angle. We need to have one more piece of information, which is the height of the plane, and luckily we are also given that height. And we know that after 5 minutes, it is 3.47 kilometers above the ground. Now, here's the thing. We know the plane's speed. We know that the plane took off at a speed of 240 kilometers an hour, and it traveled for 5 minutes. So we need to know whatever this distance is. But we're not given a distance. We're given a speed, and we're given a time. And we can use that to help figure out what that distance is. All right. So if we know that the plane traveled 240 kilometers in 1 hour, how far has it gone in 5 minutes? Right? X in 1/12 of an hour. right? Because 5 minutes is 1/12 of an hour. We could also say, boop, 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 if we don't like the hours, we could say it goes 240 kilometers in 60 minutes. How far does it go in 5 minutes? That's another way to do that. Well, and of course we could isolate for x. Right now, x is being divided by 5. So to undo the division by 5, we can multiply both sides by 5. So we get 5 times 240 over 60 is equal to x, which gives us 1200 over 60, which gives us 20. So we know that this distance here is going to be 20 kilometers. All right. But that's actually not what we wanted to figure out, although that's super important. Oops, go back. Super important in terms of finding that information for our question. That's not our final end game here. We want to know that average angle of elevation. So we want to know this guy here, and we could call it theta. Well, in reference to theta, our height of our plane is our opposite side, and our distance of the plane traveled would be our hypotenuse. And since we have our opposite and our hypotenuse, we know that that's using our sine ratio, because sine of our angle theta is our opposite over our hypotenuse. By plugging in our known values, we get 3.47 over 20. And we want to isolate for theta. Right now, theta is currently being signed. To undo sine, we inverse sine. And if we inverse sine to one side, we have to inverse sine the other. So we end up with just theta on my one side, and then the inverse sine of 3.47 over 20 on the other. And when you plug that into your calculator, knowing that we want to get to the nearest degree, we should get 10 degrees. Since we started off with a word problem, we have to end off with a word answer. So it says, what is the average angle of elevation did the plane travel over the 5 minutes? The plane traveled at an average angle of elevation of 10 degrees.
Neat.
All right, so there's some textbook problems that you could give a go.
Yes.
Word problems tend to be a little bit tricky, so I do recommend that at one point you take a peek at these, whether they be right now, tonight, or some other time down the road, but word problems are super crucial. Otherwise, that's it, and that's all.